Lesson 36, Dynamic Memory Allocation. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. All of our variables up to this point have been allocated and deallocated automatically by the compiler with adherence to the notion of scope. In this lesson, we will discuss how to control the allocation and deallocation of variables manually. In our first program, we give a simple example of dynamic allocation. We allocate an int with the new operator. The value that is returned is an int pointer which we store in our own pointer variable. Then we use the dereference operator to set the value of the allocated int. To verify this assignment, we output the value of the int using the dereferencing operator again. Finally, we deallocate the int using the delete operator. Dynamically allocated memory is kept until we deallocate it, so it is important to call delete. If we fail to deallocate, we create a memory leak, which may eventually use up all the free memory. In this program, we allocated our int with the default constructor. However, we can allocate memory with any constructor we like. Here we use the built-in copy constructor to initialize our int during allocation. To illustrate how dynamically allocated memory remains in until it is deleted, we have added a small code block which does nothing except give scope to the inside variables. Inside the if block, we allocate our memory and assign the outer pointer to point to it. After we leave the block, we can still access the memory as we do here. Then we use this outer pointer to deallocate the int. Note that it does not matter which pointer we use for deallocation as long as it points to the allocated memory. In our next program, we show how arrays are allocated. First, we ask the user how long the array should be, then we allocate the memory. Next, we have a loop to request the entry values from the user. Finally, we print the array and deallocate the memory. Here's the output when I type in 4 for the array size and 1 through 4 for the entry values. There are a few important things to note here. Most importantly, dynamically allocated arrays can have their sizes specified at runtime. For all of our prior arrays, we needed to specify the array size with a constant. There are some differences in notation from our single variable allocation too. We use brackets and the array size to allocate an array. When we deallocate the array, we need to use empty brackets. Also, array elements are always allocated with the default constructor. To avoid memory leaks, we can wrap our array allocation and deallocation in an array class like this. This class contains a constructor which allocates the array, a destructor to deallocate the array, and two functions to get and set entries. We also have a pointer which gets set to point to our allocated array. Up until now, we have not had a good use for a destructor. This example shows one of the most common uses, deallocation. By putting our deallocation in the destructor, we are assured that the memory is deallocated when this object falls out of scope or is deallocated. In our main function, we have code which is functionally equivalent to our last program, but uses our array object instead. There are a few differences between this program and the last one. First, we replaced the call to new with our object instantiation. Then, in our loop that fills the array, we call our setAt function. Next, in our loop to output the array, we call our getAt function. Finally, we eliminate the call to delete, since our destructor deallocates the memory automatically. This concludes the lesson.